Okay, so yeah, welcome to the live streaming commentary of the ACM ICPC 2015 Asia Singapore Regional. I am Jonathan.
I'm Nathan.
Yeah, we are actually the testers of this ACM ICPC Asia Singapore. Yeah, we are still NUS undergraduate student, but we are not eligible for the ACM ICPC anymore. So yeah, welcome. In this commentary, we will discuss some of the problems, and we will discuss the contest standings also with you, and also we will have a short interviews with some of the important people here in the ICPC family, in the RCD with Stephen Halim later, and we will also get one of the coach to have an interview here with us, and we will also interview one of the ICPC student volunteer that helps the ICPC run smoothly. Yeah, for most of the team, this ICPC will be the last This regional will be the last chance for them to go to the World Finals 2016 later in Phuket, because this is the last ICPC in the Pacific Peninsula region. Yeah, there are 7 Pacific Peninsula regional this year: Korea, Indonesia, Daejeon, Jakarta, Phuket, Hanoi, Tsukuba, Taipei, and the 7th is Singapore. Yeah, so this is the last chance for them. Okay, so yeah, now we are in the first hour of the contest. Let's see the scoreboard of the contest. So far, we have one team, only one team with the 4 problems solved. It's Terharu from University of Indonesia. In the second place, there is an opportunity from the Korea University. And then third, finally, we have from NUS, the host. It's Halim Army Platoon 1 from NUS Singapore.
So it's kind of interesting to see that there are actually 6 problems that has been solved so far. Of course, the 2 easiest problems from the standings, you can see that F and E are the 2 easiest problems. So there are 45 teams solving E and 43 teams of accepted submissions on F so far. The first team to solve F was No Passport from the Chinese University of Hong Kong. And the first team to solve E was Terharu from University of Indonesia. And then after that, the next problems to be solved is problem G, which is solved by Opportunity from the Korea University, which is currently in the second place. And then C is solved by Just Browsing from NUS, the home team. And then after that, the next problem, currently only solved by one team, is problem J, solved by Hydrogenous Prominence from Shanghai Jiao Tong University. And then we have National Taiwan University solving problem D, also solved by one team so far. So what do you think of the current standings, Jonathan?
Yeah, it's kind of interesting. Yeah, so we can see here that the team that get first to solve for every problems is different. So there are no teams that get more. Currently, there are no team that gets more than one first to solve award, because yeah, as many of you may know that this contest is very interesting. It's kind of like mini world finals. We have prizes for all the first to solve problems. Yeah, so it's actually interesting that no teams get more than one prize here. So yeah, so as Nathan explained before, we have 2 easiest problem here, which is problem F and problem E. F is solvable in 5 minutes and E is solvable in 7 minutes. So we are going to discuss some of these problems to you. So yeah, I think we can start with problem F. Can I have the problem description, please?
Sure.
Okay, so the problem F, you can also check in we have the open contest for all of you there that are not here in participating in the contest. You can go to open.catis.com. You will see the contest there in the open the Catis open. So yeah, you can check the problems also. Anyway, I'm going to discuss the problem F, the easiest problem that solved in 5 minutes. So this problem is about there are n intervals. I think I should write bigger. Sorry. Yeah, there are n intervals. Okay, and the n can be up to 100. Okay, so the intervals, the lower bound and the upper bound is there are these constraints. Okay, so this is the constraint of the intervals, and then we want to find how many lines we can draw such that all the intervals are cut with at least one line. So for example, if I have these intervals, okay, this is just for an example. Okay, then I can draw two lines here. Make it something like this. Then the solution will be something like this line and this line. So yeah, we need. The question is about what is the minimum number of lines that you have drawn such that all the intervals are cut with at least one line, something like that. Yeah. So this problem is actually quite some kind of classic greedy algorithm that you may or may not see before. So yeah, the algorithm for this is actually you can do greedy based on the increasing what do you call it? The endpoint of the interval. So yeah, first you sort the intervals based on the endpoint. So you sort it increasingly. It means that this will be the first interval, because as you can see here, the endpoint of this interval is the leftmost among all the intervals. Okay, the endmost. Okay, and then this will be the second interval. I think I just reorder it something like this. Okay, yeah, now it is sorted because as you can see, now the endpoints of the intervals are now increasing. Okay, and now we can just look from the first interval and we put the line as rightmost as we can. So here we will put a line here, and then we go to the second interval. Now we see that the second interval is crossed by a line already, so we don't need to put any more line. And then it's the same for the third interval. And then the fourth interval here, we see that it's not crossed by any line, so we must put a line here. And the point that we put line as rightmost as we can is so that we want to make this line cross as many intervals as possible. Yeah, because if we put a line here, it will not cross this interval. So we put it as rightmost as possible. So we put it here, something like that. And then we go to the fifth interval. We see that it's crossed by a line already, so we can just ignore and we don't add any more line. So we can see that we only need two lines for this sample input, something like that, for this input. Yeah. So this greedy algorithm will solve the problem. Yeah. So that's the quick discussion for problem F. Next, we will discuss the second easiest problem, which is solved in 7 minutes by University of Indonesia, which is problem E. Nathan, please.
Okay, so for problem E,
I will help you erase.
Okay, thank you, Jonathan. Actually, I think problem is, for me, is the easiest problem logically. Maybe it's not the easiest problem to code, but it's really easy to come up with an efficient and good solution, because it's actually something that is related to what you do as a competitive programmer. So the problem is something that we encounter a lot. So we have, like, in ICPC contests like this, right? Usually your standings is defined by how many problems that you solve and your penalties. So let's say you have n problems. Let's say A, B, C, D, E. Let's say you have 5 problems, and then you are sure that you can solve. For example, you can solve A in 20 minutes, B in 5 minutes, 10 minutes, 45 minutes, and 50 minutes. So in this ICPC regional, in word finals, we have an award for first to solve. So the first team to solve a problem will get a prize. So that means that it's possible that you have a strategy that prioritizes one problem that you really know. So for example, you really know problem D, and you're quite sure that you can get first to solve if you do it right at the beginning. So the problem is, let's say that you want D to be your first problem. What will be the maximum number of problems that you can solve, and what is your minimum penalty in that case?
So it's given the interval of the contest, is it? Is it given the time given on the contest?
The time given on the contest, yes. The time given on the contest is standard ICPC 300 minutes.
Oh, it's always 300, okay.
All times are given in minutes. Yeah. So, of course, if you have like time, like for example 301, you definitely cannot solve. So yeah, in that case, you won't be able to solve any problem, which is 0. So where do we go from here? So what do you usually do when you do a contest? Solve the easiest problem first, right? But does that strategy work in this case? Um, let's see how can we justify solving the easiest problem first. So if you see, right, let's say we solve C first, C, B, A, D, E. Then since we have D as our first, then let's put D at the start. So D, is it large enough? I think I'm blocking the. I can write larger.
Yeah, I think you should write larger.
So I think I'll rewrite this. So A, B, C, D, E. Let's say 20, 5, 15, 45, and 10.
Okay.
And then let's say you solve the problems in order of D, C, A, B, E. Then what you get is 45, and then 45 plus 15, 60. 60 plus 20, 80. And then B is 85. And then 95. And then you sum them up. So if you see, right, actually, 60 is 45 plus 15. And then 80 is 45 plus 15 plus 20. And so on. You can see that the first problem that you solve will contribute to every single one of them. So it will be repeated 5 times. So the problems that you solve first will contribute 5 times. The next problem will contribute 4 times, and so on. So in that case, we want the problem that takes the longest time to contribute as small as possible to our penalty, right? That's why, in this case, the strategy is to solve the easiest problem first. So the strategy is, after you solve the first problem, which is the problem that is given in the problem statement, in the input, then what you do next is you try to solve the easiest problem first. So you sort them by time, solve the easiest problem first, and then if you still have time, you solve the next one, and so on and so forth. So the time complexity of this solution would be n log n, which is to sort the entire thing. After you sort the entire thing, you can just loop through it. Yeah. So that's basically the idea for problem F. E. Yeah.
Okay, so yeah, very good problem here, very good discussion. So yeah, it's actually kind of quite a standard problem. Yeah, actually, this problem, the very similar problem as this actually appears in Phuket. So if you check a live archive and you go to Phuket site, it will. I forgot which problem, but there's one problem that's very similar to this problem, but the difference is they don't have the first problem to solve. So they don't have any condition that we must first solve the particular problem. You can solve in any order. So here we complicate things a bit. It's just a bit that we must first solve the for example D. It will be given in a statement which problem we must solve first, and we just do 300 minus whatever problem that you want to solve first.
Actually, one more thing, right? With n is 13, so if you try brute forcing all permutations, it probably wouldn't work. It probably won't be fast enough, right?
Won't be fast enough, but
yeah,
you can do DP bit mass, right?
DP bit mass, yeah, should be possible. But
yes.
Of course, it's much harder to code compared to this solution.
Yeah, so this is the n is only 13 for this problem. 13, 1, 3. So yeah, maybe you cannot do n factorial, but you can do 2 to the power of n, which is dp bit mass. Yeah, this actually kind of like tricking some of the contestants, thinking that the solution is quite a bit mass, but it's actually you can solve it with greedy with much less code lines, something like that. Yeah, so that's the first 2 problems that are the easiest. Meanwhile, as we discussing the problems, there are quite an interesting thing happening on the scoreboard. Let's take a look at the scoreboard. Now opportunity, after we discussed the scoreboard last time, opportunity solves 2 problems, C and I, and they solve I for the first time in 69 minutes. They become the first team that solve I. So now we have a team that solve the first problem, that solves more than 1 problems for the first time, G and I. They will get 2 awards for that. And then
Oh,
Yeah, Megabyte also solves A for the first time in 68 minutes. I don't know what's wrong to this team. They don't solve the E and F first. Maybe it's their strategy.
maybe they're looking for the first to solve a word.
Maybe, yeah, because we have awards here that it's depending on how they're working. So,
I find it actually interesting that top 5 teams are from different university. It just shows how strong this regional is. We have a lot of strong teams like from our home team, of course, and US. We have Shanghai Jiao Tong University, which has won world finals a few times before, many times actually, I think. And then we have Korea University, I think bronze medalist, right?
yeah,
World finals.
last World Finals, and two members of the three members that went to World Finals last year. Two of the three members are in this team, in this opportunity team.
And we have what else? What else? What other university do we have? Oh, University of Indonesia.
Yeah, University of Indonesia is second. Terharu, they are third. The same team. This same team are the third place in Jakarta, and the fourth we have here is a BCWOX1 BD2 from the National Taiwan University. They are second in Taipei, which just happened like several days ago. It's even less than a week ago. So yeah, it's less than a week. They in a less than a week they competed in Taipei and here. Oh, they must be very tired.
So from the top 10, we see that everyone are from different university except NUS got 3 teams. Hooray! Yay! Home
Yay,
team.
home team. Yeah, we sent 13 teams here, you know.
Yeah, we I think we're the university with most teams. Of course, it's easier to send our teams here.
We don't need any transport.
So we have 13 teams from NUS, and I think the neighboring university NTU got 7 teams, right?
6 teams.
6 teams.
Six
Okay,
teams.
6
Yeah.
teams. Yeah. So how many teams have? Oh, most of the teams have solved E and F.
True.
So yeah, those are definitely the 2 easiest problems so far.
Okay, so yeah, okay, as we discussed before, the next problem after F and E is problem G, which is solvable in the 21st minute by the team opportunity, as you can see on the top of the scoreboard. So yeah, that's the problem that we are going to discuss next. Let's take a look at G. Oh, okay, so yeah, again, as you can see on the open ICPC, you can see this problem on the open ICPC, but I will discuss the problem for you anyway. So this problem is actually kind of interesting. When we the testers test this problem, specifically, I test this problem and I got one wrong answer because of interesting thing that is going on this problem. So yeah, let's take a look at the problem. I need to erase this. Okay, so this problem G is the title is Association for the Country of the Mububa, which is not important for solving the problem. So yeah, basically the statements are quite complicated, but I just rephrase it for you so we make it more easier to understand. So basically, I just discussed what is the sample input looks like. The sample inputs are first you are given the number of numbers to come, okay, and there are 4 numbers here. Let's say 1, 2, 1, 2. Okay, something like that. Okay, and the problem here is you want to make the partitions of the number. Okay, such that the sum of the numbers in the current partition must be at least greater. Not less than the numbers on the previous partition. So one of the partition that we can do is here is 1, and then 2. 2 is the next partition. And then this 3. So yeah, as you can see, this partition, the sum is 1. Right. This partition, the sum is 2. This partition, the sum is 3. Okay. So as you can see here, 2 is not less than 1, and 3 here is not less than 2. So yeah, this is one of the valid partition. Okay. Now maybe you can say, why don't we just take them all, become one partition, and the sum is 6. And there is no condition to check because there's only one partition. So yeah, the problem here is to find what is the most number of partitions that you can make. Okay. Of course, if Okay, if the input is something like this, if the input is something like 5 and 4, okay, then you can just have everything together become 9, or you can just have a 5 and you take away the 4. So you can take away some elements from the back, okay, but you cannot take away elements from the middle or the front. Okay, so you can, because you cannot make 5 and 4, so you can just make 5 and then you take away the 4. You can do that. Okay, so yeah, so that's a problem. Okay, so that's a problem. Now one of the idea that you can get is you can do maybe you can think of greedy solution. So let's think of this greedy solution. So let's go back to the sample input given in the problem. 1 2 1 2. Okay, you can say like you every time you can create a new partition, you create a new partition. So here you can see 1, right? 1 is greater than 0. Okay, so let's say the first the partition before the sum is 0, right? So now we go to first number, which is 1. Okay, 1 is greater than 0, so we can make the first partition. Okay, and now this is 1. And then 2, right? 2, we can create another partition for 2, or maybe 2 and 1. But we already can create a partition for 2. So why not we just create a partition for 2 only? Because we want to make the most number of partitions, we want to left out some elements to create create more partitions later on. Okay, so this is 2, and now we have 1, but 1 is still less than 2, so we cannot create partition with only 1. We go to 2, 1 and 2, now it's 3. 3 can make a new partition because 3 is greater than 2, so we create a new partition. Okay, so we have 3 partitions here. Okay, so that's one idea of the greedy solution that you can think of, but unfortunately we won't have a lot of greedy solution. We won't have a lot of greedy problems, because as we see before, both E and F are greedy problems. So yeah, unfortunately this won't work. I will show you why this will not work. Let's say that we have 5 here. Okay, and the inputs are 2, 2, 1, 5, 6. Excuse me, sorry. Sorry, not 6. 5. Okay, let's say this is the input 2, 2, 1, 5, 5. Okay, let's say we do the greedy algorithm, right? We do, okay, so first we create a partition of 2, 0, 2. Okay, and here we got another 2. We can create a partition because 2 is not less than 2. We can create a new partition, 2. And now because we see 1 here, we cannot create a new partition. We must combine it with 5. Create here a new group. It's not a new partition. It's a new group, something like that. But now 6, you get 5, right? 5 you cannot create a new group because 5 is less than 6. So you cannot make a group with only 5. So you can only have 3 groups. You must take away the last 5. Okay, so with this greedy algorithm, you will get 3 groups, right? But actually, you can create 4 groups if you do it like this. Okay, so instead creating only a group of 2, you have 2 and 1 combined together. Okay, so this will be 3, and you can have this 5 and this 5. 5, 5. Okay, as you can see, this is the phallic grouping. 2, 3, 5, 5. Okay, and we can now have 4 groups. Okay, so we must output 5 here instead of 3 for this sample input. Okay, so that's why the greedy doesn't work. So now, how do we solve this? What's the correct way of solving this? So, first of all, I think I give you the constraint. So here the numbers of the number of elements can be up to 3,000. Okay, and the numbers can be 1 to 10 to the power of 9. So the list of the numbers can be very big, but it can be only up to 3,000 numbers. Okay, so yeah, we can solve this with dynamic programming. So let's formulate a DP formula, which is the DP is 2 states, I and J. This DP I and J basically means that if we just create a previous partition where the bounds are I and j, and we want to create a partitions on the elements after j. What are the most number of groups that we can create? So for example, if let's say this is the I, okay, let's say this is the I, and this is j. Okay, let's say it's a dp. If we number it with 0, 1, 2, 3, 4, then this is dp 1, 2 is 2. Okay, because we have 2 and 1 group at the previous group, and we want to create partitions on this group. Okay, so the answer is dp1 to is 2. Okay. Okay. Now let's try to formulate what's the dp formula. How to solve this? Okay, so we can just look for k, right? We look k. Okay, this is where we want to break the next group. Okay, so it's something like maximum of k. It has to be greater than j. It has to be less than n. Okay, it's dp j comma k plus 1. Okay, it's actually j plus 1 comma k plus 1. Can you see? Or maybe I write 2. J plus 1 comma k plus 1. Okay, but there's one condition that the sum of elements from I to j must not be greater than the sum of elements from j plus 1 to k, because that's the condition for us to create the group, the partition. Okay, so this formula is correct for the dp, but the problem here is the time complexity of this solution becomes n cubed, because this, as we can see, this is n squared, and here we have another loop of n, which makes it n cubed, and n cubed for 3000, which makes it 27 billion, which won't fit in under 1 second. So yeah, this is correct, but it will be too slow in 1 second. So we must change this. First of all, the optimization that we can do is, instead of looping from j, right, we can just loop it starting from, let's say, j prime, where j prime is the lowest index that this holds. Okay, so first we want to find the j prime such that j prime is the lowest index, that sum from j plus 1 to j prime is greater than or equal to sum from I to j. Since all the elements, all the numbers are positive, it cannot be negative. We can find this j prime using binary search. Okay, and then once we got the j prime, we can remove this condition now. We can just loop without any condition now, starting from j prime. Okay, we still have a loop here. We can optimize this by using how do you call it? Suffix max or something like that. So we store a d for every dp something, right? We create something like max dp ij. Max dp ij will be something like maximum from all k greater than j of dp I k, something like that. So if this is what should I say? So if this is the dp table, right? Okay, let's say this is the dp table. Okay, we will have some, let's say the max dp of this value will be the maximum of this dp and this dp of this. Okay, so it's something like we store the suffix max. Okay, if we have that suffix max, then we can compute the value of this dp quickly. Okay, because we want to look for suffix max, something like that. So if you have the dp max, we can compute this max quickly in 01 time once you got the j prime. So now we can solve this in n square log n, because you still have to find the j prime using binary search. Okay, so yeah, it's kind of complicated, but it won't be hard to code.
Yeah, actually, how long was your code for this?
How long was my code? I forgot, but it won't be long, because it's not really complicated to code. I forgot. I won't bother to check. I don't know where I stored it already. Maybe
Okay, then.
I erased it already. Okay, so yeah, this was problem G.
How many teams solved it so far? 9 teams. Nine.
Yeah, 9 teams solved it already. So far. Okay, and the first to solve 21st minute without penalty. Uh, yeah, all these threads, I suspect this is because of they attempt the greedy solutions. I don't know, maybe
Maybe like there are a lot of attempts for that problem.
there are a lot of
I
attempts.
think more than half.
Oh yeah, this problem is the lowest accepted rate. Is it 12%
Yes.
only?
It's
Oh,
a trap.
it's a trap. Yeah, it's a trap. Oh, A has less acceptance rate. It's 6% only.
A also got trap.
Yeah, also got a trap. Oh, okay. I haven't tested that one. Okay, so yeah, that's a G. The next problem is problem C that solved in 25 minutes by our NUS team just browsing. So let's go take a look at C.
I find it interesting that when they solve C, they haven't solved anything else.
Oh yeah, the just browsing when they solve C, they haven't solved E and F.
Like-
I don't know what's wrong with them.
Yeah, and then they took 30 minutes to solve the next problem.
Okay, so
So
yeah, we will discuss C. We'll pass it to Nita.
okay, so C is actually if you read the statement right, it's quite long. No, it's not quite long. It's very, very long, and most of them are not important. So let me just simplify it for you. Like this is like 1 page long. The whole page, it's it's quite long. So if you're lazy, probably you won't read it and you won't solve it. But it's actually a bit maybe not easy lah, but comparatively to the other problems, this one is easier. For example, compared to like problem K, which is much shorter, this one is much easier. Like we see that nobody has tried K, I think. Yeah. So let me try to explain. So basically, we have n recipes. So you want to create portions. So you want to create portions, and you have n recipes for the portion. And then for each recipes, the formulas are in form of, for example, I need ingredient 1, ingredient 3, 5, and 7 in recipe number 1. So this is one possible recipe. And okay, so of course, to concoct these portions, you need the ingredients that match the recipes. But there's a catch. You can also use old portions to concoct new portions. So here is how it works. So if you, let's say that we have 3 recipes, 2, 4, 6, and then you have 2, 4, and then the third one is, let's say, 2, 4, 6, 8. So the idea is that you will walk through the recipes one by one, and if you can create the portions, you will create it. So there's no choice. If you can, you must. If you cannot, then you cannot. Then, so for the first one, at first we have every single ingredient possible. So I think it's between 1 to 500,000 if I'm not wrong. So you have one copy of each ingredient. So at first, your pantry would something like this. Like you have inventory 1, 2, 3 until 500,000. So this is before you use it to concoct the portions. So then you go to recipe 1 and see that you have the ingredients for all of for this recipe. So then you can use ingredient 2, ingredient 4, and ingredient 6 to create the portion 1. So now portion 1 is created, and now we don't have 2, 4, and 6. And then for the you can actually let me try this. Oh, okay, let's make this portion number 2 instead. So let's say that this is portion number 2. You see that you need 2, 4, 6, 8, but you don't have 2, 4, and 6 anymore, right? But actually, you can use the leftover from the first portion because you use 2, 4, and 6. You can use the same 2, 4, and 6 for the next portion. But yeah, so you can use 2, 4, and 6 from this portion and the 8 from the ingredient. So you can combine them together and you get the 2, 4, and 6 here. So this one is also created. But after using this portion, you cannot use this anymore. So now you cannot use this anymore, but you can still use this. And then let's say that you want to create another portion which has 2 and 4 as the ingredient. You cannot use this one because it has been mixed with 6 and 8 already. There's no way to separate the ingredients, the portion to their components. So you can only use this if you have something that use 2, 4, 6, and 8 at the same time. So that's basically the idea of the problem itself. I know it's quite complicated, but one thing to note is that since there is no choice here, it's basically just a simulation problem, right? So you don't have any choice. If you can make it, you make it, and if you cannot make it, then you don't make it. Oh yeah, the output is the number of portions that you make after finishing. That's okay. So this is So how do we solve this, right? We know that it's only a simulation problem. So what do we need to do? So for each portion, portion number X, we need to see if we have all the ingredients, or if we can use the ingredient from the older portion. One thing to note is that since after you use a leftover from a portion, you won't be able to use it anymore. Then the ingredient must be either in our storage or in some of the cauldron. So what do we do from there? So it's just a matter of checking for each ingredient. First we check it if it's in the storage, then of course then we have it, then we use it. But the problem is, what if it's not in the storage? Then it must be in one of the previous portions, right? So we keep an array that maps ingredients to called portion. Where is the current ingredient at? So this way we can know where is our current ingredient. But there's still a problem of checking whether all the ingredients in that portion is used in the current one. Because if not, then we cannot use it, right? So what we can do is, for our new portion, we can maintain a set of what have we added and what we haven't added. So then, if we find something that is not in the storage, we loop through the portion. For example, this, we maintain a set of what we haven't used so far, which is 2 and 4 for portion 3. And then we see that 2 is actually in portion 2, right? So we look through all the ingredients in portion 2 and see if it's still in the set, which is it hasn't been used before. So what we can do, we can loop through here. So we see 2, we see that it's in the set, so we can use it. So we can remove it from the set. And then we see 4, we see that 4 is in the set, we can remove it from the set. And then we see 6 and we see that it's not in the set. That means that it's not possible to add portion 2 to create portion 3. So what we do is we move on from there. So overall the algorithm is something like this. First, let's say currently you're in portion X. What you do is, for each ingredient, initialize a with set with unmatched ingredient, which is at first it's everything. And then what you do is for the first item in the set that is unmatched, you see if it's in the storage. If it's in the storage, you remove it from the storage and you remove it from the set because now it is there, we can use it. But if it's not in the set, if it's not in the storage, you see which portion is it in. For example, in portion number Y. And then what you do is see if all ingredients in portion Y is unmatched here. If it is, then we can use portion Y to create this. So if everything matches, so if it at the end the set is empty, that means that we can create portion X. So we set all ingredients in portion X to be now mapped to portion X, so that we can use it later. So the overall complexity of this solution would be it's kind of tricky actually. It's the sum of all ingredients log. Yeah, let's say that the total number of ingredients in the recipes are m. Then the complexity would be m log m at most. Yeah, because you have the set here that contributes to the log. So yeah, that's the idea for problem C.
Okay. Yeah. So yeah, it's a great problem, including set and decision set. Is it?
Oh, actually, yeah. Another way to see if they match is actually to combine. When you combine it to a portion, you combine it to one disjoint set. That's one other way to solve it. So those are two different approaches.
Very good problems. Yeah. So this is kind of a data structure problem. You can solve it with either set or disjoint set. Very good problem. Meanwhile, in the broadcast in the YouTube, there's a one question here. How do you pronounce this? Raymond Edgar Alvarez. Sorry if I pronounce your name wrong. That's the best that I can do. He asked, is there a live broadcast on the actual contest venue? If you mean contest hall where the participants are competing, unfortunately, no. We tried to set up cameras there and using a tripod maybe to make sure the cameras still to record the contest hall, but unfortunately we can't find it yesterday, and yeah, so unfortunately we don't have a streaming for the contest hall. But you will see a lot of photos of it in Facebook. Maybe you can go to Stephen Halim's Facebook. He took a lot of photos for the contest hall, and you can see, basically you can see in his Facebook. I think he made the post public. So even though you're not his friend, you can go and check it out. So yeah, again, sorry, we don't have a streaming for the contest hall. Okay, and then let's take a look at the scoreboard here since we talked last time. Let's see what are the interesting things.
Opportunity is still in the lead.
Opportunity is still in the lead. Do we have a new problems that have been solved?
I don't think so. The rest the problems that have not been solved are B, H, and K.
B, H, and K. Yeah, it's
Quite
been the same
interesting.
since we discussed the scoreboard. Last time we discussed the scoreboard. So yeah, and the top three is still the same as well, right?
Yeah.
As last time we discussed.
Opportunity, Terharu, and Halim Army Platoon 1.
Oh, but now the hydrogenous prominence is out of top 5, and Megabyte from the Vietnam National University come in the 5th place. Okay, so yeah, we're going to take a break for a while. After this, we will have a short interview with the regional contest director of this regional, which is Stephen Halim, and we will also discuss one more problem, which is problem J, which is solved in 48 minutes. So yeah, stay tuned.
Waduh, kepala saya kepotong.
Why?
Atau duduk aja mungkin.
Just sit down.
Coba kalian duduk.
Ya.
Okay, so hi everyone. Welcome back to the live commentary of the Singapore Regional. We are now with Dr. Stephen Halim, the Regional Contest Director of the ACM ICPC Asia Singapore Regional. Okay, before I'm going to ask you several questions, we're going to discuss several questions. Let's take a look at the scoreboard. Since we have a break, before we have a break last time, there's one change here. Our Tamida solved problem H for the first time in 110 minutes. So now the only unsolved problem is B and K, which is quite tough. It's within our expectation. Yeah. So Megabyte is now out of top 5 and replaced by Awatamida because they solved H. What do you think of the scoreboard, Stephen?
Is a balanced scoreboard, means that the easy problems have been solved by most teams, the E and F. Some people have different choice of which problem to solve first. The first to solve actually F by no passport from Hong Kong University, and then after that E. So E and F are the two easiest problems. Then after that G and C. So out of these 4 problems, I think the top teams are tackling different problems. Some are doing A, some are doing D, some are doing H, I, and J. So what I can say is that we design it this way. We want the contest to have a diverse problem set, tackling different skill set or that contestant may have. So there is no one correct problem solving order. So if you read my problem E, I'm talking about problem contest strategy, right? Now I'm redefining it. There is no such thing in this contest. It means that I don't know which kind of permutation is actually the best permutation.
Yeah, so it's kind of interesting. Like there are already 9 problems solved so far, all except B and K. But the first team now only solved 6. So it's kind of like almost all the problems are solved, but none of the teams solved all the 9s.
Yes.
So yeah, kind of interesting.
We are very happy with the current standing as of the first 2 hours. Yes.
Okay, so yeah, now I would like to go back to show the camera again. Now we're going to talk a bit with our RCD. So yeah, can you tell us a bit about how do you end up becoming an RCD?
You win the contest in 2013 during my daughter's birthday, 24 October 2013, and then Asia director, Prof. Chi Jae-Huang, approached me after the contest, and he said, "Do you want to host Singapore contest in 2015?"
Oh, so just like
that.
Because the Asia director Chi Jae-Huang was there, is it?
Yeah, he was invited by the Jakarta side organizer, and he was there. It happened that after you won, he approached me. He asked Felix to tell me to talk to him, and then Felix, my brother, and after I talked to him, he said, "Do you want to host 2015?" Yeah, so that's the start. I didn't say yes at the beginning. I told him that I will think first. I eventually made up my mind a few months later. I have to go through several procedures, apply to school exco. Can we do this again? Because it will require a lot of funding, a lot of manpower, especially myself. I will need to reduce my workload of this semester just to prepare this contest. And then I need to gather a team of competing staffs, some of my colleagues, some professors for scientific committee. I need to tap in Tien and Wati from corporate relations to setting up the event, the food, the booking of vendors, venues, all of that. It takes up school resource. And after the school passed the request, then it's a formal procedure. It's a long preparation, finding sponsors, publicity, creating problem set, and so on until today.
So yeah, it looks very complicated. Actually, yeah, can you approximate like how long have you been working on this? Like
since that day, since that day, 24 October 2015, when Prof. Chi Jae-Huang asked me, "Do you want to host Singapore site?"
Sorry, do you mean 2013?
2013, yes, correct.
24 October 2013. So
So
it's more than 2 years
2
ago.
years plus, yes. So first 1 year is about making up my mind, and then getting the procedures passed, having the school support to host this again.
Mhm.
And then the second year, which is from early this year until now, is to get funding, book venues, prepare problem set, and all the way up. And because we have to also run prelim on September, so that took up a lot of time.
Mhm.
And then after that is the registration, payment, excursion between September, October, November until today. So it's basically a tough one. Somebody from other RCDs told me that the first one is the toughest one. The second one, third one, you will replicate most of it.
Hmm.
And so we will have learned a few from re-hosting this again, this ICPC regional one more time. So hopefully the second time will be much easier. Yeah, hopefully.
Okay, so you say there are a lot of challenges. What do you think? Which do you think the most challenging thing? What are the major challenges that you face during preparing all of these things?
Making decisions, because some of I don't know how many. Yesterday alone, I did a lot of on the spot decisions or several things that are happening in the contest. In the past 1 year until now, I have to decide, okay, which venue, which contest floor, laptop or desktop. Maybe eventually use laptop. Because if we use desktop, a lot of manpower needed to transform the computer lab downstairs to the contest floor upstairs. Very difficult. And then excursion or not, or which excursion? Because we have this budget, what kind of excursion do we want to do? Give a just campus tour or more than that? And food, what kind of food? Okay. This budget, that budget, this more food, less food. And problem set. This is not bad. This is special about Singapore side. The RCD actually helped choose the problem also, set the problem, be in the committee, in the science committee, because I was contestant before, I was coach before, I know how to form a good problem set. Yeah, so somehow I also solved the problem. That took me a bit, because I'm not as fast as you, so to solve that set, I will need more than 5 hours, 15 hours, 20 hours to test the set.
So the RCD
tests the problem set also. Yeah.
Okay. So you become the multi-role kind of thing.
Too many roles. So one lesson that I learned is I need to delegate more. With more people having experience hosting, I think I can delegate some of the tasks. When we host this again, I will delegate more. Yeah.
Okay, so compared to other regional, what do you think? How successful do you think this regional is?
All right, so Singapore side is lacking in some areas. Like we don't have a glamorous opening ceremony, and tonight please don't expect a grand closing ceremony. We are not good at that, but I think we can say that we are good at preparing the problem set. Especially Katis we are partnering with Katis for our contest, and they are very helpful in double checking, triple checking the problem set, so that the problem set is what the contestants are experiencing today. So that when we partner with Katis, we don't just use their online judge, but we get work final judge support, because the people behind the scene, for Austrian, Frederick Nimela, Greg Hammerly, those are experienced work final judge, our staff. So we are grateful for them for partnering with ICPC Singapore to make the contest as it is.
Okay, so you're talking about something like the first time hosting a regional is tough, but the second time, third time it will be much easier. So is that a clue that you want to say that we will host another regional next year?
Next year probably no. The current plan with Asia director is we are going to rotate Singapore side and Kuala Lumpur side every year. So the next year will be Kuala Lumpur, and 2016, and then 2017 will be Singapore again. That's the current plan. Whether it will change or not, we don't know yet. But one thing for sure is 4 years from now, Singapore is going to host IOI in Singapore. IOI is much bigger than a regional, an ICPC regional. So this ICPC regional involves about 250 person. IOI will easily exceed 1,000 people involved in that event. So there will be much more manpower needed. So this is a very good learning experience for the organizers also to prepare for 4 years to come, 4.5 years to go. IOI 2020 in Singapore.
So you're saying about rotating Kuala Lumpur and Singapore. So can we expect like at least next year or next 2 years there will be another regional here? Is it?
I will look forward for another ICPC regional Singapore 2017.
2 years from now.
2
Okay.
years from now. That's my current plan.
Cool. Okay. Yeah. I suddenly remember the last time we hold a regional is actually long time ago. It's 2007.
2007.
Maybe can you explain like what happens in this gap? Why there is this long gap that we don't host a regional this year?
I was still a PhD student by then. So yeah, there are a lot of issues. We don't have that much manpower to run ICPC regionals. Now we have people like you, people like Nathan behind the webcam, yeah, and a lot of other technical people in the judging room and in the coach room. So we can now host it again. In the past, we don't have this many people. Now we do have. So we can so maybe the timing, the kairos, the timing is perfect. When Prof. CJ Huang asked me 24 October 2013, right after you win the contest, I said, okay, if we host it in 2015, then if you go to World Final again 2014, then 2015 you can help me. Something like that. So in my mind, I said there is a probability I will have 2 extra people helping me in 2015. So that's how it turns out to be.
So it's the timing it fits on 2015. So
yes. So if it's done on 2014, I don't think we can make it because you and Nathan were not were still competing by then.
I see. So yeah, I'm out of questions actually. Maybe to end the short interview, last but not least, do you want to say something to all the viewers of this streaming?
Okay.
Anything general?
I don't know how many of you are watching this. Is this recorded? Should be, right?
What do you mean recorded?
By YouTube?
Yeah, it will come
so
out after the
if
stream.
you watch this live, then here's my message for you. If you later you watch this replay, this is my message for you. Computer programming is a sport. It's an academic sport. It's not for everybody, but if you do have talent, please spread the joy of computer programming. It's very fun to solve problems fast, but eventually it is not the end goal, really. So being a champion in ICPC regional or doing very well in ICPC regional is not the end goal, but it is a good academic exercise. So if you are if you become better in problem solving, more IT companies, more software companies, or even academia, if you go on to be a PhD student, these skills will benefit you. Your mind are trained to solve problems in creative manner. So if you train yourself like this, then you will be a more successful person in the future to solve more difficult computing problem in the future. So yeah, so spread the joy of computer programming. I hope more and more people will benefit from us hosting one more regional in this year in Singapore side. We have 57 teams competing. So with our Singapore side, they are not going to compete here. They will compete elsewhere, or maybe didn't compete at all. But we gave them memories. We gave them opportunities to compete. Next 2 years, when we host it again, 2017, it will be another group of people. If you are the one, welcome you in advance to Singapore. By then, hopefully, you are much better than today, so you can compete properly the next time we host Singapore ICPC 2017. Thank you.
That's all. Okay. Yeah. Thank you very much, Dr. Stephen. Yeah.
Thank you.
Thank you. Okay. So yeah, that's it. You can go back to whatever you're doing.
Yes,
I
thank
think
you.
you've been very busy.
I'm floating.
you're
I have a
floating.
free roll.
Okay.
Yeah,
So
thank
yeah,
you.
thank you. Okay, so next up, let's take a look at the standings one again. Okay, so now last time we see the standings, we have six. We have six problems on the first place. Now we have two teams get seven accepted, seven problems on the. Wait, have I switched to scoreboard? Yes. Okay, so two teams are now with seventh place. Opportunity from Korea and the PCW0X1BD2 from Taiwan. Now we have two teams solved A and H. Previously, there's only one team solved A and H. Now we have two teams. The other team that solved H is Taharu from University of Indonesia. They are now third, thanks to that problem. And the fourth place is now Megabyte from the VNU. Fifth place is now Halim Army Platoon 1 from NUS. So yeah, Watamida from NUS are now out of the top 5. But they are now attempting on J. And Game of Thrones are the other team that solved A. That is the second team that solved A. Yeah, and I don't think we have other teams that solved A and H. Meanwhile, B and K are still unsolved. I don't know. We still have like 3 hours. No, not 3 hours. 2.5 hours plus left. Maybe they will be able to solve these two problems. We don't know. Okay, so let's go back to the camera. Okay, now as I promised before the break, we are going to discuss one more problem. The next easiest problem. When we say easiest, is basically we look at the scoreboard and see which problem are the first problem solved. So it's after F, E, G, C, we are going to discuss J because Shanghai Jiaotong solved it in 48 minutes. So yeah, let's take a look at problem J. Sorry. Okay, it's an association of cats and magical lights. Once again, if you have a user in the open Katis, you can see it on the open Katis. I think the contest name is Open ICPC Singapore or something like that. ICPC Singapore for public or something like that. Yeah, you can see the problems there. Anyway, I'm going to describe what the problem statement for you before discussing how to solve it. Okay, so for problem J, the question is you are given a tree. Okay, the n is the number of nodes. It can be 300,000. I hope it's big enough. Okay, big enough. Good. And you'll be given queries. There can be up to 1 million queries. Okay, and the queries can be one of the following. So, first of all, all the nodes in the tree are given a color. The color, excuse me, the color can be 1 to 100. Okay, that's the possible color. Is it on? All right. This is not connecting to the internet. Oh, yeah, not off. Okay. Yeah. So the nodes can be colored with any possible color from 1 to 100. Okay, and the query, the query can be either one of the following. The first query that you can do is you change the color of a node. Change color of a node. One single node, okay? And again, the color even after you change can be only from 1 to 100. Okay? And then the second query that you can do is you pick one node X. No, it's not you pick, it's the input. So there will be one input X, and you want to find in the subtree where the root is node X. Okay? In the subtree where the node is where the root of the subtree is node X. You want to find how many magical colors are there in the subtree. Okay, here the magical colors is defined as the colors that occur in the odd numbers, odd number of times. Okay, so for example, right, I will give you the sample tree that are given in the problem statement. So this is the tree. Okay. Okay, and let's say the color of this is 2. This is 1, 1, 1, 2, 2, 2. Okay, so suppose this is the tree. And suppose I want to find the query, the second type of query, in this subtree. Okay, so the subtree where this node is the root. Okay, now there is only one magical color here, which is 2. Because 2 only appear one time. But 1 here appears 2 times. Okay, so it's even number of occurrences. It's not a magical color. And the rest of the colors in this subtree occurs 0 times, which is an even number. Okay, let's say 0 is an even number. Okay, so if the query is this subtree, then you must answer 1, because there's only one magical color, which is color number 2. Okay, so yeah, this is what the problems looks like. Okay, if we do it a brute force way, we do it naively, then of course we can support the first query in O1. Let's say we want to change the color of this node to 3, we just change it to 3. Something like that. But the query can be very expensive. Let's say we always query the root, right? If we query the root, we need ON to check all the colors of all nodes. Right? We need ON to check the colors of the nodes. Which means in total we need N times Q operations. 300,000 times 1 million obviously will not run in 1 second. So that's not the correct way of solving this problem. Okay, so let's discuss what is the correct way of solving this problem. Okay, so this is quite we will do the standard trick to solve this kind of a tree problem, right? Okay, let me remove this. First of all, let's renumber the tree, the nodes. I mean the nodes. Okay, so because the number of these nodes may not be comfortable for us to do the query, so let's renumber it. Okay, the way we renumber it is we do DFS from the root, and we change the index of the node to become the DFS number. Okay, but I mean DFS number is when do you visit the node. Okay, so when you do DFS from this node, right, this will become 1, this node will become 2, and then since you DFS, you visit this node first before you visit this node. If you visit this first, it become BFS. Okay, so we do DFS, this become 3, this become 4. Okay, and because this subtree is finished, we now DFS on this node, this become 5, 6, 7. Okay, now why we renumber these nodes like this? Because we will have an interesting thing here. If we see on this subtree, right, all nodes from this subtree are numbered from 2 to 4. Right? If you renumber the nodes like this, if we take any subtree, the nodes that are inside that subtree, the numbers are consecutive. So it must be an interval. If we see the whole tree, right, it's 1 to 7, something like that. Okay, this subtree is 5 to 6. Okay, so that's why we renumber these nodes. So every subtree, the index are the list of the index are consecutive, ordered, something like that. Okay, so now every time you let's say you want to query, right, how many magical lights from 2 to in this subtree, right, in the subtree where the root is 2, right, we can just query from 2 to 4 using a fast rated structure, which we will see later on. Okay, so now the question is about we want to find how many colors appears odd times. Okay, so we can change this using bits. So it's either 1 or 0 now. So let's say these nodes, right? These nodes computes. These nodes have 100 values. The first value of this node stores how many times the first color appear on this subtree. Okay, so let's say this node is a color 1, this node also color 1, and this node also color 1. Okay, so we want to store 3 here, but instead of storing 3, we can just store 1, meaning that it's odd. Okay, and if there's an update on 5, let's say 5 we want to update to any other else, 3, let's say, we just change it to 0. Okay, and if, for example, 2 becomes 1, the color of 2 becomes 1, then we update to 1. And if there's another node that becomes 1, we change it back to 0. So we XOR it with 1, something like that. Okay. Now suppose there's only one color. We can do these operations by using, you can use binary index tree or you can use segment tree. Okay, let's assume there's only one color, which is the color number 1. And we want to see whether that color has odd number of occurrences or even number of occurrences. So you can just, because all the queries, right, all the queries are in the form of interval, we want to find whether from 2 to 4, how many number of 1s are there. Okay, or it's not exactly how many numbers of 1, we just want to find is it odd or even. Okay, so we can just using, let's say we use segment tree, we can just query 2 to 4 using segment tree, And every time we update, right? For example, we want to change from, let's say previously the color of node 3 is 2, and we want to change it to 3. No, if we, let's say it's 1 and we want to change it to other color 2, let's say. Okay, then we must switch, we must reduce the number of 1 in this subtree, and how to say, we must reduce the number of 1s in 3. So every time you query 2 to 4 or maybe 1 to 7 later on, the number will be reduced. Okay, and if we have multiple colors, we can just have 100 bits. Okay, we can just have 100 bits to store whether this color have odds or even number of occurrences. Okay, and after we get 100 bits, we can separate 100 bits using two long longs. Okay, one for 50 bits and another one for 50 bits. And once we got the 100 bits, 50 bits and 50 bits, we can count the number of how many bits are turned on, how many bits are 1 using the. If you are using C++, you can use a built-in pop count standard library to count the number of how many bits are turned on in I think it's constant. Yeah, it will be quick. It will be fast to use a built-in pop count standard library. So this problem is solvable using you can use binary index tree or segment tree. The trick here is to have for each node of the segment tree you have each node in the binary index tree you have two long longs storing whether this range has the even or odd numbers of nodes for each color storing in the bit. Okay, so yeah, this is the 5th easiest problem so far, problem J, which I think so far only 8 teams solved. Yep. But it's not so hard. It's not that hard actually. Okay, let me erase this first. Oh, actually, I just read something that's not covered on the camera just now. Sorry, I drew the line too high. Okay, so yeah, we only discussed 5 problems, which is actually Stephen wants us to do that because we have another problem discussion here, which is after the contest, so we will not reveal all the problem discussions. But instead, we will just discuss the rest of the problems, only the problem statements, the rough idea of the problem statements to use, so you get the feel of what is the problem is all about. So yeah, the rest of the problems are H, A, B, I, D, and K. So we will start with problem H. Again, we will just cover the rest of the problems, only the rough idea of the problem statement. So problem H, Nathan?
Oh, problem H.
H was right.
Oh,
right.
I'm doing H.
Yeah.
Okay, so problem H is actually, I think, one of the simplest problems by this description. So basically, we have a square-shaped land in Singapore, which is not too big. The size is 4 times 10 to the power of 7 times by 4 times 10 to the power of 7. So both sides it's 4 times 2 to the power of 7. And then in this piece of land, you want to build a building. But there are a few restrictions to the building. You have something in mind for the building. So you want it to be shaped as a convex polygon. So a convex polygon is a polygon where all the angles are less than 180 degrees. So it's something like this. This is one possible example of a convex polygon. And so this is not a convex polygon because this angle is more than 180 degrees. So other restrictions that you must follow is that each coordinate must be on lattice points. That means that it must be, for example, in 1, 1. It can't be in like a fractional number or irrational number or complex numbers. I don't know how would that work. So for example, 1.5, 1 is not allowed. So you can only build a point on your polygon at the point where both the coordinates x and y are integers. And then, of course, since you have this piece of land, your point can't be outside of this land. So the coordinates X and Y must be less than 4 times 10 to the power 7, and it must be a non-negative number. And then all of the vertex must be on distinct points, so you can't put the same vertex twice. And then it can't be collinear. Something like this is not allowed. You cannot put 3 vertices collinear. And it must be convex, as we have said before. So all the vertex that you put must form a convex polygon. So it must be a convex polygon. So something like this would be a solution. So you are given n, which is the number of vertices that you want to build. The problem is whether you can. You should output the vertex. So you should find a place to put all these vertices so that it satisfies all the conditions before.
So now,
yes.
So now we don't check whether all these points are convex. We want to generate the points, is it? So it's not like a reverse question. Usually we check whether this polygon is convex or not given these points, but now we want to give these points and let the judge check whether it's convex or not. Something like that. So it's reverse.
Yeah, it's more like a constructive problems which is starting to gain traction in the competitive programming world. We start seeing more and more of this kind of problems where you need to build like something like build a test case, build something, given a condition, build something. So this kind of problems has been gaining popularity lately.
Yeah, I've been seeing these kinds of questions lately, usually in code forces actually, using constructive problems, and they are usually interesting.
I think it's maybe one of the reason is how because like setting checkers is easier now compared to a few
Oh, you
years
mean
ago.
the custom judge?
Yeah, custom judge. That might be the reason why.
True. Yeah, maybe.
So yeah, that's problem H. Basically, the idea is simple. Given n, create a convex polygon with n vertices so that the coordinates are between 0 and 4 times 10 to the power 7. So that's basically problem H. I think 2 teams have solved it so far. The first team to solve it is RR Watameda, home team. And the other one is Terharu from University of Indonesia. So yeah, that's problem H. And then after problem H, we'll continue with another problem. Two connected problems, problem A and problem B, titled Association for Cool Machineries Part 1 and Association for Cool Machineries Part 2. By the way, if you have ever noticed, every single problem here, the title is abbreviated to ACM. It's quite interesting.
Purposely do that.
Yeah. It's quite funny. So let's start with problem A. This is another long problem. The problem statement is like 3 pages, including the sample inputs, outputs. But the idea is quite simple. Like a lot of it are just images, like graphics. So basically, you have a robot. So you have a robot, and then the robot has commands. So they have like a program. For example, the possible characters in a program is a string of characters, is this, or this. So this is a more than sign, this is a phi, this is the caret sign, and this is the less than sign. So each of these represent the directions. As you might have guessed, this is right, this is down, this is up, and this is left. So when your robot, for example, your robot is placed on a grid. For example, something like this. Let's say, I think the robot starts at a certain point, right? Am I right? Let's see. Oh yeah, we have a grid, and then okay, it will always be enclosed in a wall. So in the grid, dot means empty space, and the hash sign is a wall. So the first and last column and first and last rows will always be a hash sign, which means that it's closed, it's enclosed, and you can't get out. And then you will also have an R inside the grid, which signifies where your robot is now. So you are given the grid and the program of the robot. For example, something like V down, right, right, down, right, up, up, right, left, left, down. Given this kind of program, your robot will run it character by character. So first down, the robot will move from here. The robot will move down, and then the robot will move right, and then right, up, right, down. So basically, and after it has finished everything, it will start again from the first character. So it will continue circling around this. And so this particular pattern must repeat, right? So the problem wait.
Sorry, what happens if the
Yes.
robot is on a place and it says go right, but the right is a wall?
Yeah, that's right. If the robot must move to somewhere that has a wall, then it doesn't move at all. So
Oh.
it just got stuck, basically.
And it will move. It will continue on the next
Yes.
command.
Yes,
Okay.
it will just skip the command.
Okay.
And then, okay, so the pattern must repeat, right? For example, after on this command, when the robot starts here, it will basically go through everything once and then repeat the same thing, right? So there's a definition here called a trail, if I'm not wrong. Okay, so let's say that a trail is something like this. So we have, it's like the sequence of positions. So for example here, this is row 2, column 1. So 2, 1, and then, wait, row 2, column 1, yes. 3, 1, 3, 2, 3, 3, 3, wait, no. 2, 3, 1, 3, 1, 2, 1, 1, and then it will repeat again, 2, 1, and so on, right? So this is this sequence is called the trail. So this is the trail of the bot for this case. And then since at some point it must repeat, right? For example, in this case, it repeats around here, right? So basically it will look something like there must be a certain suffix of it that repeats. So a part of it, for example, for this one, from here downwards, it repeats again and again and again. So you want to find the smallest integer, basically smallest repeating suffix. So for this one, it will repeat every 8 times, right? So in this case, the answer is 8 because it will repeat this 8. It will repeat this 8 sequence infinitely. So the answer is 8. Another example, if we have something like this, if we have something like this, R is here, and then the program is right, then the sequence, the trail would be 3, 1, 3, 2, 3, 3, 3, 3, 3, 3, and so on, right? It will get stuck here, and then it won't move anymore. So in this case, the answer would be 1, because the sequence 3, 3 would repeat indefinitely. So this is what we're looking for in this problem. So it's actually quite the problem statement is quite long and a bit complicated, and there's this definition of a trail. Yeah, so actually the problem itself is quite long. but it doesn't stop a few teams from solving A. So I think three teams so far have solved A, with the team Megabyte from VNU solving the first to solve this problem. So this is problem A, right? Problem B is quite similar, not similar. It's actually the constructive problem of problem A. So basically, we have this problem, right? Problem B is write an input for this, so the answer will be at least 1 million. That's it. So write an input for this so that the output of that test case is at least 1 million. This is a bit difficult because of the limitation in problem A. So for problem A, like the size of the grid n is less than or equal to 200, and then the length of the program is also less than or equal to 200. So it's actually a bit hard to construct a test case so that the output is more than 1 million, at least 1 million. So that's actually problem B. So yeah, it seems to be a very hard problem. I think nobody have tried this problem at all. Like not even a single submission, 0%. 0 submission, 0 accepted, 0 wrong answer. Yeah, I think it's kind of the simplest problem here. Like it's only half a page.
Yeah, so to solve B, I think we must understand the problem in A first, and I think you also need to solve problem A first, right? To make sure you understand it well. Very well.
Yeah, if you have a code for A, then at least you can check your input for problem
True.
B.
Yeah, you can test your outputs on problem B whether it will get accepted or not.
Again, this is one of the problems that have a constructive fail on it. Like you need to construct the input.
We have two problems constructive here, which is
B and H.
quite
just now.
interesting. Yeah. H we have two people solve it, but for this problem B we haven't seen any people even attempt it.
Personally, I think B is harder than H.
Do you think people will solve it in 3.5 hours left? No, it's sorry, it's 2.5 hours left. Yeah, 2.5 hours left.
Actually, I'm not sure. It's really hard to guess because like for this kind of constructive problems, right? You have to have that kind of intuition to it. Like, how do I construct this? How do I start? Where do I move from here? And then if it's not good enough, do I need to start over or
Continue trying to optimize?
Yeah,
something like
that. So it's actually kind of interesting to see which team will solve it first. But honestly, I don't think it will be solved.
You don't think it will be solved?
I don't think it will be solved.
So
let's see if this is right.
Megabyte from the VNU have solved A since like, I don't know, 1.5 hours ago. 68 minutes. It's like 1.5 hours ago. I don't know what they're trying to do now. Maybe they will try to move to B because they have solved A for a while ago. But
maybe, but like since nobody have tried B, then I don't think that's the case. Because it's really hard to jump to a problem that nobody have solved unless you're looking for the first to solve a word.
Yeah. So now for those of the teams that haven't got the first to solve a word, there are two chances left, which is B and K. The rest of the problems have been solved. Anyway, let's take a look at the standings. Okay, so yeah, let's take a look at the standings once again. Now we have the team that get 8 problems solved, which is a BCW0X1BD2. Sorry if I get wrong. Maybe you intend to pronounce it other way. So yeah, we can see that team that I just mentioned just now is the only team that solved 8 problems. I think they just solved A in several minutes ago, 14 minutes ago, and jumps to the first place. And now the second place is Opportunity from the Korea University. Have I switched to Scoreboard? Yeah. 7 problems. And then Taharu, Watameda, and Heterogeneous Prominence. So we can see here that the top 5 is not fixed. We can see that the top 5 are changing every time we see the scoreboard. So this is a very interesting contest. Just now several minutes ago we see Megabyte and Halim Army Platoon 1 in the top 5, but now they are in a 6 and 7. So you can see that the top 5 is changing, which is a very good race here. Halim Army Platoon 1 just got a no on problem A. And let's see whether we can get an interesting thing here. Let's take a look at the statistics. Hope you can see it. Yeah, you can see it. B and K, again, as we say just now, B remains unsolved and unattempted, which is on the case with K. K is indeed the hardest problem that we intend to create. We intend K to be hardest. Later, after the second break, we will discuss the rest of the problems again, just the descriptions, because we don't want to discuss problems too much. PCW0X1BD2 just got a no on H. They attempt on H. Meanwhile, there are two pending submissions on the top 5. Opportunity attempt on A and Watameda attempt on I. It's still pending. Let's see where we got some interesting stuff here. Since the last time we discussed scoreboard, more teams have solved A. Hydrogenous prominence also solved A just several minutes ago. Meanwhile, we will have some kind of a short interview with one of the coaches. Welcome. Hi.
Hi.
Hi. Yeah. Where's the camera?
Oh, hi.
Camera. Maybe you can sit down because you're too tall. Okay. So. Yeah. Hi. This is Mr. Denny. This is one of the coaches from the team that is here competing.
Mhm.
So yeah, I'm going to have a short interview maybe.
Okay, sure.
Okay. So first of all, which university are you from?
From University Indonesia.
Oh, University Indonesia. So yeah, I believe it's in Indonesia
Yes,
according to
of
the
course.
name. Yeah. So yeah. How many teams do you send here?
We sent 2 teams. The good thing is my best team is currently ranked 3 at the
Oh.
moment. Yeah, let's hope that they can do they can solve more problems.
So that is
Oh, now it's number 4 now.
so it's
Yeah.
Taharu from
Taharu.
University Indonesia, and
The
I
other
believe-
one is arbitrary fractal pattern.
which is 23rd now.
Yeah,
and
23rd
they
now.
solved that
Yeah.
problem. 3 problems. Okay,
Mm.
how do you select these team members? Like, do you have an internal selection test or something like that?
Yeah, I mean, in the past, we allow students to form teams by themselves, in the past, but it turns out it doesn't work really well. So in the last 3 years, I select individuals.
Mhm.
So basically, I select like the top 12 individuals, and then
Okay.
I form the teams by myself, looking at their, their capabilities. So it turns out it works well, and then we got first time in World Final 2 years ago.
Oh,
Yeah.
okay. How do you select these 12 members, the individual? How do you do the selection test for the individuals and get the top 12?
Oh yeah, we got like 1 month or 2 months selections.
Mhm.
So we got like a contest, like and then we have problems they have to solve. And then we also look at their what do you call it, performance in like code force.
Code force.
Yeah,
It's a very good platform.
yeah. So we encourage them to participate in those kind of contests.
So you see their ratings on code forces, something
yeah,
like that.
code forces. Yeah.
Oh, okay. And
Yeah.
then among these 12, you just pick like the first, second, and third to be first team, fourth, fifth, and sixth to be second team, or you do some kind of.
Oh yeah, and
what do
we,
you-
we don't automatically like select the first 3
Oh, you
to
don't?
form.
Okay.
Yeah, so first I ask, but normally it's like that. But we ask them, they can choose their partner, their preference,
Mhm.
to be with who, and then I take into account that preference, but
Okay.
also need to have like a balanced team, like cover all aspects of this competitive programming.
Oh,
So like
true.
like mathematics, I have to have at least one good in mathematics,
Mhm.
and one data structures and things like that.
Mm. Okay, yeah, that's a good strategy
Mm.
actually for this kind of contest, because
Yeah.
ICPC have no syllabus. The problem can be anything under the sky. It
Yes,
can be
that's
like
true.
mathematics. I've also encountered a lot of physics problem.
Yeah.
It can be anything under the sky. So
Yeah,
it's,
especially like in the last in the no, no, the world final 2 years ago, the problems more like physics and
yeah,
things like that.
there's
Yeah,
physics problem, and
Yeah.
it's good that we can have a teams that one member that is good on this, one member is good on this, so we
Yeah.
have breadth knowledge, something like that.
Yeah, because starting 2 years ago, we also allow students from other faculty, like faculty of mathematics.
I see.
They can
Okay.
join this internal contest.
Mm.
Formally, it's more like only for computer science students in our uni, but we allow them to compete, and then it's a good thing as well, because bring different perspective,
Yeah,
Yeah.
true.
Mm.
Yeah, so for the teams that compete here, the Taharu and the which is arbitrary factor pattern, do they have any particular strategy? Is it like some members from the Taharu is the one coding and the rest are algorithmics, or do they have any particular strategy?
The strategy, I let themselves to define their own strategy.
Oh, okay.
But after I form the teams, and I ask them to practice as a team, so they can they can find out what's the good team dynamics between them.
I see.
Yeah. But one thing that I'm make sure that I ask them to read all the problem statements, like in the because make sure that they all read the problem statements, especially the one that unsolved at the moment. Let's say at the moment, if they haven't solved like problem B, everyone should read that problem.
Because sometimes no teams have solved it, but it's actually easy for them.
Yes.
Yeah, it's actually easy for them, but not for every other team.
Other member,
Yeah.
For example, the three of them, one thing that problem B is hard, but for the other team, they might, I've done that problem before. Yeah.
So yeah, even though nobody have solved it, they should read that problems and aim for the first solved award maybe. Because we have an award for that. And I think we give power banks.
Power banks? Oh, really?
I think so. Yeah, we give power banks for all the first to solve award. So yeah, we will give out 11 power banks.
Oh, that's good. That's good.
So they can aim for the first to solve award as well. Yeah, but anyway, that's for strategy. That's up to the team whether they want to aim power banks or not.
Yeah.
So looking at the current scoreboard, right? I think we can show the scoreboard here.
Yes. Okay.
Yeah. Taharu is currently 4th, and the arbitrary factor pattern is currently 23rd. Yeah. So what are your expectations with the teams? Like, what if you can speak to the team, right? What will you ask them to do? Something like that.
Okay. Frankly speaking, this is a very tough competition. Yeah, the opportunity is the Korea University was the medalist from the last world
they have
final.
2 world finals.
2 world final
Members.
and then members, and then the team from National Taiwan University, they won the rank 2, right?
Yeah,
from
second in Taipei.
Second in Taipei. So our Watameda is the first winner in Jakarta.
Yes.
So this is very tough contest, but I hope that the problem set also good, like the Stephen said. I hope they can solve, like looking at the pattern, like they have to be careful in problem A, because lots of wrong attempt as well over there. Just look at the other then I hope that they also start working in parallel. Because otherwise they might not have enough time to solve more problems. Maybe they split, like one working on one problem and two the other problem at the same time,
so they can solve more problems.
Sure.
So let's take back the camera.
Okay.
So what do you think about the contest? Because I think this is your first time participating in a Singapore regional, right?
Not really.
8 years ago you were here?
Yeah, 8 years ago. First time as a coach, I sent a team to National Nanyang Technological University in year 2000, I think.
Oh,
yeah.
Okay. So
So
you've been a coach for a very long time.
yeah, and then I went to my postgraduate studies, and then I'm back, and then start coaching again. Like I think in year 2011 or 2010.
Oh,
Yeah.
okay. So yeah, looking at the contest so far, the yeah, you can take transportation, accommodation also into account. Do you think what are the good and bad things about this regional? Like
Okay.
you can compare also with the year 2000 in NTU.
Okay.
What do you think about this regional?
This regional, I think first is the problem set is good, so we don't have to worry because I about the problem set because we participate in one regional and the problem set is not really good, and that's really frustrating, you know. So now we can rest assured the problem is good. So that's one main thing. The other the the other thing is maybe um, the coach need Wi-Fi.
Oh yeah, that's
Yeah. So we all need the Wi-Fi internet access. Normally in other regionals, we can get that access to
okay.
the
Yeah,
internet.
no,
Yeah.
I will let the committees.
Yeah,
The
we got some. Yeah, some of us got the Wi-Fi, but not all of us.
Oh, okay.
Yeah, that's a small thing. A small thing. But
Okay.
in general, I'm impressed with the contest. I think you've done good job, and then
Thank you.
especially like with this, you know, commentary, it's really good. It helps others to learn as well. Yeah, I think it's good, very good.
Okay, so yeah, if yeah, Steven said we are going to host this like next year or next 2 years. We are alternating with Malaysia, Kuala Lumpur. So
Okay.
yeah, if we organize this, let's say 2 years from now, will you send your teams here?
It depends because here is the competition too strong.
Oh, okay. It's
Yeah,
because it's
something.
too strong.
Yeah,
But it's not because other committees are slacking or something like that. Right?
no, because the competition is too strong.
Oh,
I have
okay.
to.
It's because of that. Okay.
Yeah. Like now, you see. I mean, like the member. Yeah, because it's like Stephen said in the opening. This competition is the last in the Pacific Peninsula
Yes.
region. So if people, if those teams didn't get any their luck in the previous regionals, and they will send teams here. So it's gonna be very tough.
Yeah, they will like all out here. They will try to their best here because this is their last chance to go to work finals. Yeah, I think this will be tough.
Yeah.
They will go all out, something like that here.
Yeah, and it's really like Stephen said. I mean, even like in 2 years' time, you will do this regional approximately about in December as well.
Yeah,
So,
true.
yeah.
Because before December, all of these rooms are still used. The SR1, the contest hall are still used for examination. So yeah, we cannot make it this earlier. So yeah.
Okay.
It's already earliest that we can do actually. Yeah. So yeah. This is not your first time in Singapore. I have this question here. Is this your first time in Singapore?
No,
You've been to NTU before.
Yeah.
Do you enjoy Singapore? How do you compare it to your country in Indonesia?
It's somehow it's hotter here.
Yeah, true.
yeah. I didn't expect that. You know, I thought like being living in Jakarta is hot enough. You know, but here is hotter and then more humid compared to Jakarta. So,
because we are nearer to the equator, right?
Yeah,
I think,
yeah.
Singapore is nearer to the equator compared to Jakarta.
Yeah. But at the end, I mean, the rest is I enjoy Singapore. It's good. Yeah.
Okay, so yeah, last before ends this interview, the last but not least, do you want to say something to all the viewers that watch this commentary?
I would say that like enjoy this, enjoy programming, enjoy competitive programming, and I think you can do a lot with programming, and with competitive programming, you gain skills, and then that skills is very good for your future, especially for the students. So yeah, invest some time to do this problem solving, and it's really good for your career later on.
Yeah, I agree. This kind of problem solving, competitive programming is very useful. How we think about problems, how we do problem solving is very useful for later, for future. So yeah, so
Okay.
that's all I think. Yeah,
Okay.
Thank you.
Thank you.
Denny.
Okay.
Okay. Yeah.
See ya. Bye.
Thank you. Bye. So yeah, before we have another break, let's have a look at the scoreboard here. Uh, okay, so yeah, I think is it changing then? Yeah, so Watameda has solved 7, which is problem I. They overtook the Haru and now they are third. And now there are two teams solve 8 problems, which is opportunity and BCY BCW0X1 BD2 from Taiwan. Uh, so now other than that, nothing much changed. Oh, now Halim Army Platoon 1 is back on top 5 because they solved I just several minutes ago. And yeah, that means hydrogenous prominence is out of top 5. Meanwhile, B and K are still unattempted. So yeah, we're going to have another break for like 15 to 20 minutes. We're going to take some rest. We are quite tired here doing the commentary. Before we have a break, let me answer some of the questions that are on YouTube. YouTube chat. Is there any live scoreboard? Yes, there's any live scoreboard. We provide the URL in the bottom of the commentary. And other than that, no more questions. Great organization, thank you. Great contest, also thank you. So yeah, there's no more questions. So yeah, I think we're going to have a short break for 15-20 minutes, and we'll be back soon. Thank you. Okay, hi. Welcome back to the live streaming commentary of the ACM ICPC Singapore Regional. Now I'm with one of the student volunteer. His name is Jonathan. He's the same as me, but different last name. So yeah, this is a student volunteer that helps ICPC runs smoothly. So yeah, we're going to have a short interview.
Yeah.
Okay, sure. Yeah, you should be NUS students, right?
Yes.
All the volunteers are
We are
NUS
all
students.
different.
Which major are you from?
I'm from mathematics.
Oh, mathematics. Wow. Okay. Which mathematics?
The pure one.
Oh, pure mathematics. Okay. So, yeah. So, how is the volunteer recruitment process like? How do you end up become a volunteer here?
Yeah. First one, the volunteer doesn't depend on the major. Is you are not to has to be a math or computer science student. It's open to all NUS student from all year 1 to, and even we have one graduate student in our
Oh,
team. And
okay.
for the selection, yeah, we are having some like one interview with the head manager, and yeah.
Come closer. Yeah.
Come
Okay.
closer. Yeah, and after the interview, we are given the result, and we are all get it for the team, and we are given our position. Either it's team guide or a setup guide.
Oh, okay. So, what kind of interviews is it? You say you are interviewed. No, not interview. Selected by the
Interview.
interview. Let's say. Yeah. How is it about? What's the interview like?
The interview is about how we manage in teams. Because we have some people who are becoming the leader of the guide leader or the setup leader. Like how we work with the team and work with other people, because we are representing NUS, and we have to preserve NUS good name.
Oh, okay. So, oh yeah, they even have a selection for that, which is good. So they don't just take anyone who applies
Yeah.
it. Okay, good. So yeah, sorry. You say there are team guy and setup guy, is it? Which
Yes.
part are you? Which role are you?
I'm team guide. I'm guiding
Oh.
team from Indonesia,
Which university?
from Gajah Mada University.
Oh, okay. So, yeah. What do you think about the team? Are they like friendly? Are they like yeah? What do you think about the team in general?
Yeah, most of the team are friendly. We are like outside of the competition.
Mhm.
We are also having a time together, like having a dinner, know each other. Because it's our responsible also to make the team welcome to the Singapore.
Mhm.
But also the team is doing the good work. Like having a good relationship with all the other team, and also for the student ambassadors.
How do you end up with them? Do you choose them? Do you like say you want to have them as your students, or you
Our
assign?
manager already assigned them to us.
Also, it's not your choice, but
Not our choice.
I see. Okay, so yeah, actually, what exactly the jobs of the ICPC volunteer?
Yeah, first
What do
one
you do?
for the setup guide
Mhm.
is probably a lot of setuping the contest arena,
Okay.
or like for the food and for the bus. But for the team guide, mostly the team guide should guiding all the team for 2 days. For 2 days full, we are guiding everyone to go to the other part of Singapore, or
Okay.
just like let them know around NUS, because NUS may be a bit confusing for a newcomer.
I see.
But for the team guide, we have a unique job, because like in the competition for 5 hour long, we are not interacting with the students.
Mhm.
So we are having a job. Either it's a balloon or a invigilator,
Oh, okay.
balloon runner.
Okay, yeah. Yes, as some of you may know, ICPC has this kind of balloon tradition. It's been for the last several years already, where when you solve a problem, you get a balloon. So yeah, this ICPC volunteer guide, when they are not when it's the competition, because they cannot guide their team, they are the one that running to give the balloons. So yeah, is it like that?
Yeah.
Okay. So yeah, do you enjoy being this volunteer? Like if yeah, Steven said we will hold like next year or maybe next 2 years. So if you have this kind of regional again, will you be? Do you want to be a volunteer again?
Absolutely, because like the atmosphere is very different. At first, I think like a competition will be like very intense. Everyone is very focused on solving the problem, and in the day one, maybe everyone is like focusing on the competition day. But it's all different. The atmosphere is fantastic, and it's friendly, and like very interesting, and also the competition day even is also interesting with all the balloon and the colorful things and the friendliness is amazing.
So you enjoy.
Yeah.
Cool. So yeah, have you read some of the problem statements? What do you think about the problem statements? Have you read them?
Do you mean the problem?
The problem statements, yeah.
Yeah, I think some of the problem are very interesting. I have sometimes to like just skim on the problem, and like actually at the guide room,
Mhm.
the Ilvan Yahya, the author
Of the most problem, yeah. He
Yeah.
read most of the problems.
he's actually discussing the problem B to all guys,
Or to all the volunteers.
to all his volunteers, because he always say that problem B is difficult but it's doable to everyone because it's like solving a puzzle. So like all our off guide, we are getting together and listen to problem B.
Yeah,
and
so
it's-
problem B, even though you're not a computer science guy or you don't any fancy data structures of these algorithms that most CS people know, you don't need all the stuff. You just need it's like solving a puzzle. So
Yeah,
you
solving a
don't need
puzzle.
CS background. Yeah, it's kind of interesting actually. So yeah. Other than that, other than problem B, what do you think?
Actually, I'm
Okay.
just focusing on problem B.
Oh, okay, yeah. Yeah, especially for mathematics, you're usually interested in this kind of stuff. Yeah. So, yeah. Before we end this short interview, last but not least, do you want to say something for everybody that watch this commentary?
I think this commentary is very good because I want you all to know that how all the ACM ICPC is going on. All the event is very interesting, and you can always watch us in live to know what are happening here.
Oh.
Okay,
Okay, so that's all.
that's all.
Okay. Yeah, I think that's the end of the short interview with the student volunteer. So thank you,
Thank
Jonathan. And you may go
Yeah,
back to
thank you,
your work.
Jonathan.
Jonathan, both of us are Jonathan. Yeah, you may go back to your work. I think you are pretty busy back there.
Yeah.
Yeah. Okay.
Okay,
Thank you.
thank you.
Thank you. Okay. Next up, we will take a look again at the scoreboard. Let's see what's happening here.
It's very interesting. The top 5 has changed a lot since we last met. So, Opportunity and the BCW0X1BD2, that team, those two teams has been going back and forth, like first place, second place, first place, second place. And meanwhile, at the third, fourth, and fifth, we have battle between two NUS teams, Halim Army Platoon 1 and RR Watameda. They both solved 7 problems with only 1 penalty point separating them.
Ooh, yeah, it's 1 penalty points.
It might change because, yeah, RR Watameda haven't solved A and Halim Army Platoon haven't solved H, which I think both of them are doable.
Both of them are doable, yeah. But Watameda already got 2 incorrect attempts on A, which means they got 20 minutes penalty at least. So if both of them solve the A, I mean Watameda solved A and Halim Army Platoon 1 attempt H, and it is Watameda just got up. But they didn't solve A. What do they solve?
They solved
They solved D instead.
D. Wow.
Okay. So yeah, it's kind of a bit tricky. I've heard from a lot of committees.
Yes, it is tricky. I solved that.
Okay, solved that, and it's kind of tricky. So yeah, we can see those that solve. None of them solved in the first attempt, so maybe tricky. So yeah, and okay, Platoon 1 is currently 4th, just now kicked by Watameda from 3rd, and now in 5th place is Zillions. I think never in top 5 before.
Yeah, they just got in top 5 when they solved H, I think. They solved I and H in 4 minutes.
I and H in 4 minutes, and they go up to 5th place.
Yeah, they solved 2 problems in 5 minutes. So that took them up quite a lot.
I see. Meanwhile, the top 5 from before is the Terharu. They just kick out of the top 5. Now they are 6, with 6 problems left, and with 6 problems accepted. I mean 5 problems left. Meanwhile, B and K has still B and K remains unsolved. Yeah, as you can see here. Wait, let me turn on the camera. Yeah, we have the balloons for B and K here. B is this gold color thing, and K is the green balloon here. So no team have got this balloon yet. I take some balloons to the commentary room here to show you guys.
We take some balloons here because
We think that
not many people will take the balloons. So
not many people will take the balloons, so yeah, we're sure that we have enough balloons back there.
Yes, we
because
can take some.
we can
Yay.
take some. Yeah. Hey, okay, so let's go back to the schedule. after the standings discussion, okay, as we promised before, we'll discuss the rest of the problems, which is I, D, and K. Again, because we have discussed 5 problems and the solutions, we will discuss the rest of the problems. Just a brief summary of the problem description. It's Stephens wants us to do that. So yeah, let's go take a look on I. Okay, problem I. Oh, I should erase this first before.
Actually, the rest of the problems, I, D, and K, I think I and K are quite simple in the description.
In the description, but not
solving it.
Simple to solve it. Okay, so yeah, indeed the problem I is not quite difficult. Basically, we are given A numbers of apples and C numbers of cherries and M numbers of mangoes. So we have 3 fruits: apple, cherry, and mangoes. We are given A apples, C cherries, and mangoes. So we are given 3 numbers ACM. We want to find the number of permutation of these fruits, such that no 2 same fruit are neighboring. So for example, right, in the sample, we can the sample input says 1, 2, and 1. So there are 1 apple, 2 cherries, 1 mango. Okay, so one of the valid, so the output is 6. I will list down what are the possible permutation: ACMC, CACM, CAMC, CMAC, CMCA, and the last is MCAC. Okay, so these are the 6 different possible permutations that you can have. Oh, actually, this is kind of disturbing. I will take it out first. Okay, so yeah, as you can see here, there is no permutation something like CCAM because we have 2 neighboring C's here and it's not allowed. So yeah, we don't want this. So yeah, that's the problem. We want to find the number of permutations. Of course, it can be big, so don't forget to modulo 10 power of 9 plus 7. It's a standard number in modulo. So yeah, the number of each number A, C, and M can be up to 2 power of 10 power of 2 times 10 to the power of 5. So standard dynamic programming, which is n to the power of 3, will not work here. Which the states are how many apples have you put, how many cherries have you put, how many mangoes have you put. It will not work because this number cube is a very big number. So yeah, this will not work. Yeah, this problem involves quite complicated. I should say it's complicated, right? It's not simple, right? Quite complicated combinatorics.
Honestly, yeah, it's very, very complicated. Like, for me, if I have to explain the solution, I don't think that people will get it in one.
Okay, so yeah, it's quite complicated, and currently only 5 teams have solved it, which is currently the top 5 in the standings. Okay, so so before we continue to discuss the next problem, let's take a look at the questions on the YouTube chat. It says Khalid Khal. It asks, how many teams will proceed to WF 2016? We're not really sure.
Yeah, because it's hard to say. Each region, they have like their own rules, right?
Yeah, each region have their own points allocated, and some of you may know the point allocation is quite weird. All the local teams have different points than all the foreign teams, and teams that repeat teams have qualified from another team has also different points allocation. So it's kind of hard to say how many teams will proceed. But if you are watching your team from your university is on the first, rest assured it will be qualified. Yeah.
If you want to see the details of your rules, you can see CJ Huang's blog, the ICPC directors. They have the rules over there.
Yes. So now actually the first one is opportunity. Currently, if the scoreboard stays like this, the first one is opportunity, which is from Korean University, and actually they will not taken into account at all because they are medalists from last year, and the rule says we can just ignore all the medalists. They will just qualify to World Finals immediately, so we can just take out that. So now we can consider the first place is Taiwan University, something like that. Yeah, it's a lot of rules, a lot of exceptions in in the rules of how many teams the qualification of WF, so we can't be sure about that. Sorry about that. Okay, that's all the questions on YouTube. Meanwhile, we don't have any questions on Twitter. All the questions are here in YouTube. Okay, so let's just continue to the next problem, which is, I forgot, D. Okay, so you want to erase this for
Okay, then I.
okay, so the problem actually have some stories, but I will just rephrase it. So I will take out the story, and I will just make it some kind of math paper, something like that. So I'll just remove the story. Okay, so yeah, basically we are given the we are given a number k, and this number k are given in the prime factorization. So we are given up to 350 prime numbers, which basically means that it is the prime factorization of k. Okay, so given 35 prime factors. Okay, and these prime factors can be repeating. Okay, the 2 may appear more than once, and all the prime factors are guaranteed to be only inside 2 to 99. So it can be at most 2 digits only. Actually, it will all given in 2 digits, so the 2 will be given as 0, 2, something like that, but it's not important. We are given 350 prime factors of k, and it can be only, 97 actually. Yeah, 97 is prime. So it can be only at most 2 digits. Okay, now we want to find the factorization of k. Let's make it a times b, something like that. We want to find a and b such that a plus b is, wait, I forgot, minimum. Is it? Yeah, minimum. Okay, this is the problem. Actually, it's not exactly like this. I rephrase it to become like this. There's a story behind this. There's this thing called bytes and servers. You want to send it to servers. I remove all the stories to make it more simpler. Yeah, this is the story. So this is the problem. So let me give you a sample here. Okay. Suppose the prime factors are 2, 3, and 2. Okay, I hope you can see that. Yeah. So it means that the k is a 2 times 3 times 2, which is 12. Right. Now the way we can make a plus b minimum is to set a equals to 4 and b equals to 3, which means the sum is 7. Okay. If you want to make 12 and 1, 12 and 1 becomes 13, so it's less optimal. Okay. So the way to optimize this is to make 4 and 3, which is 7. Okay, so that's a problem. And of course, because it can has 350 prime factors, the numbers can be very huge. You must output the result modulo again 1 million plus 7. Okay, it's standard number in modulo problem. Okay, so that's the problem. Actually this is not all, because I think if I only give you this, you won't be able to solve this, because the key point to solve this problem is on the additional constraints of this problem. Okay, so there are 2 more conditions of the number k, which is first, each prime factor, okay, will not appear 100 times, will not appear more than 100 times. So the k cannot be constructed like 2 to the power of 101 or something like that. Okay, each prime factor can only appear at most 100 times. I hope you can see that. Okay, and then I think we write 2 on that side. Yeah, how you say that? And then the second condition is okay, k has at most 10 to the power of 10 divisors. So this is the additional 2 constraints that applies on k, not on the inputs but on k. So yeah, these are additional conditions that helps solving the problem. The problem involves some kind of a divide and conquer on this number. You divide it into 2 lists, and you some kind of meet in the middle or something like that. So yeah, this is a very important number that because of this number we can divide it into 2 lists, 10 to the power 5, 10 to the power 5, something like that. Okay, so that's problem D. And next is problem K.
which is I think one of the simplest problem here, like to explain,
But not to solve.
but not to solve. Of course, if you see the standings right now, nobody have attempted it. Have anybody attempted K?
Let's see.
Nope, no one.
No. And meanwhile B has one attempt, but
Agricoder.
it's from Agricoder. They haven't even solved A, but they attempt B straight.
Ah,
I don't
that's
know what they're
interesting.
doing.
Maybe they accidentally submitted the wrong problem.
Maybe. Yeah, it is probable. Okay, so yeah, let's just go to quick discussion on K. Again, just a brief discussion on the problem statement.
Oh, okay. So, problem K is, again, I think one of the simplest problem to explain.
It's just like H. Is it? Those
H.
questions that quite
Yes.
easy to explain but not easy to solve.
Yes. So basically, the idea is that you have endpoints. For example, here, 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 and then so you want to put a camera. Let's say that these are cats. So there are points where a cat is there. Then you want to put a camera. Let's say you put it here. Let me use a different color. Do we have different color? Yes. Let's say you put a camera here. You want to see, you want to cover K cats. So endpoints and cats. You want to cover K cats with a single camera that can reach the radius of R. So let's say that. So okay. So you want to find the minimum R. Find minimum of R, so that you can cover. So that you can do this. So you can cover K cats out of the N cats. So what do I mean by find the minimum of R? So it means that we can put a camera with radius R, for example, something like this, something like this, so that K cats are covered. So we want to cover K cats with a single circle with radius R. So we want to find what's the minimum radius possible. Sounds simple, right? But this is actually, I think one of the hardest problem here is also shown in the standings as well. So the constraints for this are N is between 2 and 100,000. K is 2 or 200. But there's one more constraint, right? For all the test cases, either one, K is less than or equal to 20, or N is less than or equal to 5,000. So either one of these will apply. So K is less than or equal to 20, or N is less than or equal to 5,000. So yeah, this is probably either this or K is the hardest problem here.
What is the constraint of the
the
location of the dots of the points here? Can we make use of the constraint of the points?
I think
Maybe they're
it's quite large.
small.
So X and Y are less than 1 million, is it?
Oh yes, 1
it's
million.
1 million, so I think it's quite large. I'm not sure what to do with it.
We can't use the constraint for that.
Yeah, maybe like if you manage to, for example, like use only one of the coordinates, maybe we can do something, but 10 to the power of 6 squared is quite large. It's hard to do something on it.
Yeah, we cannot try for all possible before something like that because
Actually,
10 to the power of 6 square is a very huge number.
One, because it's very huge number. Second is that because
You mean not on the point integer.
yes, this may not be an integer.
True.
Like everything, the cats are always in an integer coordinate, I think. But the camera can be anywhere. The output is a double, so it's a radius, a floating point number.
Yeah, so this is in some sense, we want to solve two separate problems, is it? Where the first problem is this is the n and this is the k. And the second problem is the n is small but the k is huge, something like that.
Yes, something like that. So it's actually quite interesting.
So
Maybe
kind of like hybrid things. Two problems, we want to solve two problems in one problem.
maybe, but it's possible that there's a solution that can cover both. I think we do have, if I'm not wrong. Yeah, I think the solution can cover both. We do it this way because it's easier to kill solutions that, for example, rely on n or rely on k. I think we do. I'm not quite sure myself.
See. Okay, yeah. Anyway, this is the problem that we expect to be the hardest.
Yes.
Or B, but we expect it more to K.
Yes.
So yeah, we put it on last in the discussion. So anyway, it's 7 minutes before we approach the scoreboard. Let's take a look at the scoreboard again one more time, and let's see what are the interesting things here.
Not much has changed since the last time we looked at the scoreboard.
Last time we looked at the scoreboard, Watameda only attempted once on air, or twice.
Yeah, twice.
Twice.
Now
Okay.
they have 3 attempts.
One more attempts. Meanwhile, Zillions also attempt on A. They try to secure their top 5 positions, or maybe even get a better place. I think they will go to, if they solve A, they will go to 4. Yeah, they will go to 4.
I think A should be doable. Like in the last 1 hour, A should be doable.
In the frozen standings.
Actually, I think when we tested this problem, I think A was the first problem that I look at it and then, oh, this is easy.
The first problem that you look at and solve it, is it?
Yeah, like when I look at it, I instantly know how to solve it. So I thought that would be easy problem, but apparently it's not so easy judging from the number of accepted submissions.
We have 9.
9, only 9. Yeah, I thought that would be quite simple compared to, like, for example.
Okay, yeah. We can wrong.
Yeah,
Expectations we can expect wrongly. Meanwhile, D has only 3 accepted
Yes.
so far. Yeah, we expect the three hardest should be B, D, and K, right?
Yes.
We do expect that. H and I is the
I is
4th and 5th.
I is because it's a combinatory problem, right?
Yeah, I am
You need someone with good maths. Right.
probably H is H is the convex problem. Okay, so yeah, that's the scoreboard.
So what do you think, Jonathan? How many problems will the winner solve?
They have 1 more hour left, right?
Yes.
Do you think? I'm not sure whether either both of them can get B. I think it's impossible for them to get B and K because K, is the solutions are quite complicated, so it's quite impossible to solve both of them
It's quite hard
in
to
1
do.
hour. But do you think they can solve B?
Honestly, it's hard to say. B is something that if you get it, you get it. If you
Yeah,
don't,
it's
you
kind
don't.
of like where you think the way you think. If you think it on the correct way, you will get it somehow. Is it like that?
Yeah, I think it's something like that. Like if you accidentally went into the wrong direction, then you're screwed.
Okay, so okay, yeah. So
What else?
yeah, what we can say is it's very unlikely that a team will finish all the problems, which means we can
Probably at most 10.
most
But-
10, sure.
Depends
Yeah.
on whether the top 2 teams can solve B, or maybe RR Watameda can solve A and B, or and K.
Okay.
K
In
I'm
1
not
hour?
sure. K in 1 hour, probably not.
Probably not. Meanwhile, Taharu is attempting on D. I think if they get D, they will go back to the top 5, maybe 5th.
They apparently are quite low.
240. If they add another 240, it becomes 645 plus the
Fourth.
penalty. 4 or 5th. So they
Or-
can still in
I think
the
it's 5th. Yeah.
around 4 and 5th.
Yeah.
They can still in the top 5 of definitely. Zealand's quite bad on the start. They got a lot of penalties there, unfortunately.
They only got here like a few hours, like last hour, I think.
True. Game of Thrones. They attempt on H. If they got 1 more problem, means that
No, it's still very
240,
big.
800.
Like there will be 6.
No, it's 5th.
Eh?
240.
Oh,
You add 240, you got 800.
Yeah,
You got 800, you will be 5th. So yeah, it's
can be in top 5.
yeah, it still can be in top 5, and it's quite interesting. Meanwhile, heterogeneous prominence is now down to 8. They quite often get in top 5 in the earlier part of the contest.
Yes.
Don't know what's wrong with them.
They haven't solved anything since 160. They haven't solved anything since
Their last AC
Wow.
submission is
2 hours and 40 minutes. So that's probably why.
3 megabyte is even worse. It's 132 and they haven't got anything after that. Meanwhile, 11 we have 2 EG, 2 AC. They have just solved I several minutes ago. They are the second in the preliminary, right?
Second in preliminary, yes, yeah, they are. Now
They're
they
quite-
yeah.
They are 11, but they are attempting on A and H. I don't know what's wrong. And then, something's wrong. Something's changed. Yeah, see, 2 EG, 2 AC just got A.
Just as we talked about
Just
them.
just as we
Now-
talked about them, now they move and they got A. Yeah, and 2 minutes
Now-
before the frozen standings.
Yes.
So it's still all the teams that solve A is not their first attempt. It's kind of I think the problem setter is laughing right now because he can set. It means that he can set a very tricky test case that almost all of teams got trapped on that test case or maybe different test cases also.
I can totally imagine him laughing.
Okay, yeah. So let's find other interesting things before we froze the scoreboard
It's
and
1 minute before scoreboard. Before the scoreboard will be frozen. So let's just wait and see if there's any more
Any more last minute
submission. Not last minute
change
last
before
minute change
frozen.
before frozen. Yes.
Last whatever that thing is.
35 seconds. Let's see.
Meanwhile, there's no more questions on YouTube, and let's check the Twitter. There's no questions on Twitter. No?
20 minutes.
I mean, 20
Sorry,
seconds.
20 seconds. Yes. 10, 9, 8, 7, 6,
You're acting like it's almost the end of the
4,
contest.
3,
Usually, this kind of countdown is
1.
for the end of the
Yay.
contest.
Now it's frozen. There will be no change to the current scoreboard. So let's just see who can get who will the scoreboard change? We don't know.
We don't know, yeah.
Anything can change during the last hour.
Anything can change, true, and we will not refill it until the end of the closing ceremony. I
Yes.
hope I don't open the full standings. Okay, this is I believe this is the pending standings.
Yeah, the scoreboard was frozen. Yes.
Okay. Yeah. Okay. So yeah, I don't think we can discuss anything from now because the scoreboard will stay as it is. So yeah, we'll end our live commentary here. I think you want to say something.
I guess thanks for watching. I think it's a nice experience both for me and I hope it's been an enjoyable experience for you as viewers as well. So yeah, I hope you enjoyed the commentary and thank you for watching.
Yeah, so from me, yeah, that's all. Again, as Nathan say, it's been a great experience. Thank you for watching, and as Steven said, we will host another regional maybe next year or next 2 years, alternating with Malaysia. Make sure you guys participate on that if you are still eligible to participate. Promote it to your friend in your university, so we can have more teams. We can have bigger, better regional. So yeah, see you all next time, next 2 years or next year or next 2 years. Thank you. Bye bye.